Okay, welcome back, and we are in the discussion for 2.7, which is one-to-one functions. This becomes important in pre-calc 2. We're going to talk about it now. I mean, it's important now as well. But let's take a look at, we'll say, problem number 6. So we're asked to find the inverse, or f inverse of x, for the function f of x equals 1 over x plus 3. Okay. So the first thing that I would do is to rewrite this. It's in function notation. I would write it just with a y. So y equals 1 over x plus 3. Right? And then swap. The y becomes an x, the x becomes a y. So x equals 1 over x plus 3, or excuse me, y plus 3. We can buy that that's a y, right? And then solve for this y. And to get this y out of this denominator, I have to take this entire binomial out of the denominator. That is to say, I have to multiply both sides by y plus 3. The y plus 3 cancels, so I get this y plus 3 times x is equal to 1. And there's a few things that I can do. I can distribute that x through if I wanted to. I don't want to, I just want to divide it. Because I have something multiplied by x, I can get rid of the x simply by dividing it. And that leaves me with y plus 3 equals 1 over x. And then I subtract 3 from both sides, and I get y equals 1 over x minus 3. And that's one of the answers. It's the correct answer, so there we have it. All right, let's look at number 7. Seven is the same question, except we're looking for f of x equals 5x over x minus 6. And this one's a little bit more involved because there's two x's in the right-hand side. But I'll go through the same process, write it as y equals 5x over x minus 6. Replace my x's and my y's, so this becomes, I should have given myself more space. So I've got f of x equals 5x Alright, so again I'm going to start with y equals 5x over x minus 6. Switch them, so this becomes x equals 5y over y minus 6. And I want to solve for my y, and there's 2, and that's what makes this a little bit interesting. But I still want this y minus 6 out of the denominator, so I'm going to take this and multiply it by y minus 6 on both sides. Right? Then it gives me x, and I'm actually going to distribute this x through. So I get x times y minus 6x equals, the y minus 6 cancels the denominator over here, so I just have 5y. Now I have two y's, but they're no longer in a numerator-denominator situation here. So what I'm going to do is take the x, y, and subtract it over to the right-hand side. Get all of my y terms on one side. I'll carry this up to the top. And so I have negative 6x left on the left-hand side. And then I have 5y minus xy on the right-hand side. And it may not look great now, still, but I can factor a y out of these two terms on the right-hand side, and that's where the magic happens. I've got this negative 6x equals, factor a y out, and now there's only one y. Right. And I can divide 5 minus x from both sides. It cancels on the right hand side, leaving with just a y. And then I have negative 6x over 5 minus x. And I have my inverse function. In this case, this, as it's written, is not there, but if I take the top and multiply it by -1, and I take the bottom and multiply it by -1, which I can do because -1 over -1 is still 1, I'm going to change the way this looks without changing its value. So the top now becomes a positive 6x, the bottom becomes -5 plus x, but -5 plus x is the same thing as x minus 5, and this answer is there, right? So sometimes you may have to manipulate your answers, right? The other option was way back here, I could have subtracted my 5y to the left, and I would have avoided this -1. But if you're on a test, if you're on a test where it's all electronic and on the internet, like we're probably going to be for the rest of this semester, you'll need to know how to manipulate your answer to become one of the answers. If you were on a written test and you wrote this first one, you'd get it right. All right, let's look at number 8. All right, number 8, same question, but I have f of x equals the square root of 3 plus 7x. Right. So again, I start off with y equals root 3 plus 7x, and then change. So x equals 3 plus 7y. And I want to isolate and solve for that y. So this y is stuck in an expression under a square root, and I can undo that by squaring both sides. So that leaves me with x squared equals, the square kills the root, leaves me with 3 plus 7y. I can get this y term alone by subtracting 3 from both sides. Take this upstairs. That leaves me with x squared minus 3 on the left, and 7y on the right. And then I get the y completely isolated simply by dividing both sides by 7. And I'm done. X squared minus 3 over 7 is my y. And that's it. Hopefully this helped. I'll see you guys for the next one.